One of the most attractive tools that we can find among the QGIS plugins is 3D visualization. QGIS itself has its own tools. However, the QGIS 2.3JS plugin allows us to export this 3D visualization and share it. To begin, we add the vector layer of buildings to the project. Next, we load the satellite image from Bing. We make sure that the project projection is 32618, which is the UTM projection for Bogota. It is important that the units of the project projection are in meters. We open the attribute table of the buildings. We are interested in two variables: the type and the height expressed in number of floors. Both variables are fictitious. We have prepared them so that the exercise shows the potential of the tool. However, both the type of the building and the height are randomly assigned. In the properties of the layer, we modify the symbology to the one categorized according to the type of building. We can check that the colors have been assigned to the buildings. Now we are going to proceed to the QGIS 2.3JS plugin. We look for it in the Manage and Install plugins and install it. Activating the tool opens a new window. To begin with, we can see a list of project layers on the left-hand side. First, we can see the DEM and the only option, Flat Plane. We activate its box. In the central panel, a three-dimensional model is displayed. With the mouse wheel, we can modify the zoom. With the right button, we can move in the plane, and with the left button, we can rotate the model. Next, we activate the box of the Bogota buildings layer, and with the right button, we enter its properties. The object type has to be changed to extruded, and below we modify the height in the height field by clicking on the epsilon symbol. We have information on the number of floors in each building. To obtain its height in meters, we multiply this height expressed in the number of floors by an average height of a floor, 3 meters. On the expression form, we delete the number that is there by default and select fields and values in the central column, and specifically the height field. In the expression, we add the asterisk and the number 3 and confirm. In the model, we can see that the buildings have already gained height and that the vector elements can be displayed in 3D. However, another element can be added to this model. We add the digital terrain model to the project. We open the tool again, and now we deactivate Flat Plane and activate our DTM. We enter its properties, and in the Material section we activate the Layer Image option that allows us to visualize the texture of a layer, which we select with the Selected Layer button. In the list, we select the Bing layer and confirm. However, the buildings have disappeared. The solution is simple. We enter the properties of the building layer and modify its Z coordinate. The mode will not be absolute but relative to our digital terrain model. By confirming, we can see the buildings represented again. At first, the rotation of the model is linked to the base of the whole model. With a left click on a building, we select Zoom in here, and the rotation is already linked to the surface of the 3D model. We can see that not only the buildings have been visualized in 3D, but also the relief with the mountains and so on. To save this result, we enter the File menu and select Export to Web. We select a folder where the result will be saved, formed by some folders and some files. It is very important to check the Enable the Viewer to Run Locally box, and the template will be 3D Viewer. We export and open the result in our browser. We can navigate in our 3D model, and above all, we can compress this folder and share it with our colleagues or clients as a very attractive way of presenting the results of our work.